Okay, good evening, everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is Humble Kliman, your mentor. So today we shall be looking at these questions under simple harmonic motion or vibrations and motion, and we are going to prove just how to come up with the formula for the total energy uh, 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 which happens to be E, or represented by the letter W, and then we are also going to do these practice questions under simple harmonic motion. Let's get started. A spring that obeys Hooke's law has a spring constant K. Show that the energy stored E in the spring when it has been extended elastically by an amount X is given by that formula. Okay, so now for you to solve this particular question, okay, so this is going to be my solution. So the whole concept here is this: if you have a spring, okay, if you have a spring of this kind, and then let's say this spring has got a mass attached to it, which we can call M. If you push this spring in this location using a certain force, you expect a change in the displacement by some amount X. Okay, now remember that as you're applying a force, there is a certain energy due in this direction, which we are calling as your KE, but this spring will have a desire to get back to its initial position, and at the initial position you have this particular energy, which are calling as the potential energy. So together, the total energy is going to equal to potential energy plus kinetic energy. Okay, now the total energy under simple harmonic motion is given by the formula 1/2 spring constant Ka to the power 2, where A might equal to X. Okay, that is when, yeah, okay, just that. So we can use this particular concept in order to calculate this particular question. Now, how are we going to solve this particular question? Now, there are certain formulas that I would want you to know under simple harmonic motion. The first formula is for the displacement. X is going to be given by A cosine Wt plus phase. The second formula is going to be acceleration equal to negative A W power 2 cosine Wt plus phase. C is the velocity, which is going to be given by A W sine Wt plus phase. Now, if you know these formulas, you are able to solve this particular question. Okay, so now let's get started. We know that kinetic energy, we know that the total energy is given by 1/2 Ka power 2. Okay, then we know that the potential energy is given by 1/2 Kx power 2. Then we know that the kinetic energy, which is Ke, is given by half mv power 2. Now, if we know these formulas, then we can solve. So we know that total energy is equal to potential energy plus kinetic energy. And from what we have these formulas there. So where there is total energy, I will replace with 1 over 2 Ka power 2. Then where there is potential energy, that is total energy, potential energy, I will replace with Kx power 2. Then where there is kinetic energy, I replace with with mv power 2. Now, remember that the velocity was given by the formula AW sine WT plus phase. Then, of course, x was given by the formula A cosine WT plus phase. Now, we can replace. So this is going to be 1 over 2 K A power 2, okay, is going to equal to, okay, then, all right, so in this case, I don't even have to write this particular formula because that is what I just want to prove. Okay, it's okay. Let's write it like that. What is on the right and the left should be the same. So this is going to be 1 over 2, then K, where there is x, I'm going to put that formula. So it will be A cosine WT plus phase. Okay, then power 2. Okay, then power 2. Like that. Plus 1 over 2, where there is m, I just put it like that. But V is A W sine WT plus phase. Okay, that is power 2. Then we are going to have 1 over 2 Ka power 2 equal to, so this is going to be 1 over 2 K, then 2 to the power A, that is going to be A power 2, A power 2, then that is going to be cosine power 2, then WT plus phase. Okay, then this is going to be plus 1 over 2 M, then this is going to be A power 2, then W to the power 2, then sine power 2 WT plus phase. Now, I want you to know something. Omega is represented by the letter W and it is equal to K over M. So if we square root this side, we are going to get omega or W to the power T to the power 2 equal to K over M. Then, where there is this guy, I can replace with this. So, I'm going to get 1 over 2 Ka power 2 equal to 1 over 2. Okay, like that. Then this is going to be, A to the power 2, then cosine that to the power 2, then plus phase. Then my work is going to be this side. I can put my M there. Then, of course, my A there. Then, where there is W, I can replace with K over M. Then, sine power 2. Then, WT plus phase. Okay. Then, that guy and that guy can cancel. So, I'm going to get 1 over 2 Ka power 2 is going to equal to 1 over 2 Ka power 2 cosine to the power 2. Then WT plus phase plus 1 over 2 Ka to the power 2. Okay. So the K is here and I've put it here. Okay. Then we've cancelled the M. So then this is going to be sine power 2, then WT plus phase. I think I taught this on Telegram. Now, notice what is going to happen. We are going to have 1 over 2 Ka to the power 2 equal to, we have 1 over 2, we have 1 over 2, so we factorize. We have K here, we have K here, so K is also common. We have A here, it's also common. Then we're going to remain with cosine power 2 plus phase, and then plus sine power 2 plus phase. Okay, like that. Now, notice that what we have here is a trigonometric identity. Sine theta, sine power 2 theta plus cosine power 2 theta is equal to 1. So everything here is going to equal 1. 1 multiplied by this is this. So at the end, we are going to get 1 over 2 Ka power 2 equal to 1 over 2 Ka power 2. Now, remember that this is the formula for the total energy which we have here. So we can replace total energy henceforth is going to equal to 1 over 2 Ka power 2. So we have proved where this particular formula is coming from. Okay, so to just go on further to prove, we can say that since x is equal to a, where there is that guy, while there is this guy, we can replace with so we can replace with it. So that is total energy is equal to 1 over 2 then k, where there is a, we can replace with x, then that is going to be power 2. So of course this is where we are going to end from, and we have proven that this particular formula holds. So that is just how you prove. Let's go to the second question. So the second question is simply saying a 0.5 kg block attached to a light spring oscillates on a frictionless horizontal table. So let's collect the data. So data, of course, we have been given the mass. The mass is 0.250 kg. And then we have been told that it is attached to a light spring which oscillates on a frictionless horizontal table. Okay, so I'm going to draw what is happening here. We have been given the amplitude to be 0.125 meters. Okay, and then we have been given the velocity to be 3.0 meters per second. Okay, it passes through the equilibrium point when x is equal to 0. Find the spring constant. So to find the spring constant, of course, we know that we have been given the velocity. We are going to use that formula. Okay, which formula are we going to use? So we are going to use V is equal to root of k over m, then a minus x. Okay, so of course we can make that the subject. So if I put my power 2 this side, even this side my power 2, so we are going to get V power 2 is equal to that guy, and that guy will go. So we are going to get k over m, and then I'm going to get a power 2. So of course we want to make k the subject, so it's going to be cross multiplication, and we are going to get v power 2 m equal to ka power 2, then over a power 2, like that. So of course when we cancel, we are going to get k is equal to v power 2 then m over a power 2. So of course let's try to find our answer. We see what we are going to get. What is our v? Our v was 3 power 2. What is our m? Our m is 0.25, then everything by what is a? A was 0.125. Okay, so let me try to punch on my calculator. I see what we are going to get. So we are going to have this is 3 power 2 3 power 2 . Okay, so 3 to the power 2, where is power 2? Okay, 3 to the power 2, and then we have 0 0.25, then everything all over by, this is going to be 0 0.125. Okay. Okay, so let me restart. So 3 to the power 2, 3 to the power 2, then it's multiplying, sorry for the delay, 0 0.25, then everything all over by 0 0.125 power 2. Okay, power 2. Okay, so we are getting a 144. Okay, so we are getting a 144. So our K is going to be 144. Okay, 144 Newton per meter. That is just how you solve this particular question to this state. Calculate the total energy of the block system. Okay, so total energy is equal to 1 over 2 Ka power 2. So total energy is equal to 1 over 2. We have the 144. Then what is our A? From the data, our A is 0 0.125. Okay, so we have 0 0.125 power 2. So let's try to see our total energy, what we are getting. So of course, we have 0.5 multiplied by 144 multiplied by 0 0.125 power 2. Okay, power 2. We are getting a 1.125 joules. Okay, we go to this third. Find the block speed when x is equal to a over 2. So the block speed v is equal to 1 over 2, okay, root of k over m a minus x. In this case, we have been given that ax is equal to a over 2. Okay, so we can calculate. So what is a? A, we were given to be, okay, it is 0 0.125. So we just say x is equal to 0 0.125 over 2. Okay, what are we getting? So 0 0.125 divided by 2, we are getting x equal to 0 0.0625. Okay, so of course we do our replacement. This is 0 0.5. Okay, this is going to be what is our K? 144. What is our mass? Our mass was 3. Yeah, sorry, our mass was 0 0.25. So we put 0 0.25, and then here we put our A, which was 0 0.125 minus 0 0.0625, like that. Okay, so when you do that, whatever answer that you are going to find, okay, let's just proceed. So this is going to be minus 0 0.125. Okay, so 0 0.125 minus 0 0.0625. Okay, so we're getting that number. Okay, so we have 0 0.5. Okay, so 0 0.5. Okay, then we say the square root of 144 divided by 0 0.25. We're getting a 48. Okay, our velocity is going to equal to, so 48 multiplied by 0 0.5, yeah, 0 0.5, and then multiplied by 0 0.0625. Okay, 1.5. So this is going to be our velocity, is going to be 1.5 meters per second. That is just how you answer these questions. If you find this video helpful, consider subscribing and also hitting the like button. Don't forget to join Telegram, where work is being made easy for you. Thank you so much.